Finding zeros using the TI-83 calculator. TI-84 is pretty similar. Now there's ways of doing this by hand. Hopefully I've made videos available to you either in this video or somewhere else to where you can see those. But if not, what would I do? So finding zero is the same thing as saying set these equal to 0 and solve. So if I were to set this equal to 0 and solve, I'm just basically solving x plus 2 equals 0. Subtract 2 from both sides, you get x equals -2. Now with the graphing calculator, what we're going to do is type in y equals x plus 2 and then graph it. Now zeros is the same thing as x-intercepts. X-intercepts are always of the form x comma 0. So there's several ways that we can find this value. One thing is to look at the graph where it crosses the x-axis, because that's what x-intercepts do. They intercept the x-axis, and it looks like it's crossing at -2. So one thing you can do is look at the table, which is yellow. So it's second graph, and we're gonna move up a -2, 0, where y value 0 is our x-intercept, also known as our 0. There's other ways to do it. We could also just assume that we believe it's -2, then we can hit the trace button and then hit -2, enter, and it confirms that we got y equals 0, so therefore -2 is a 0. And there's a couple other ways underneath the calc key, second trace. You actually see the word 0 too. So it asks for the left bound, so we can take our left arrow, or right arrow, but left arrow in this case, go to the left of where it's crossing the x-axis and hit enter. We can take our right arrow and move it, or we can just pick any number to the right of -2 because that's where we think it is. Say for example +2 and hit enter. And you'll notice that we have the where it's crossing the x-axis in between those two arrows. And for guess, it really doesn't matter if you move it or not, just hit enter. And there it is, 0 is -2. But the way that I'm actually going to do it, because I think it's the easiest way, is I'm going to hit y1 or y equals enter, and I'm going to actually graph y equals 0, which is going to be the x-axis. And it's already graphed. You can't tell, but it is. And once I have that in there, once again, I got the equation, and then I have y equals 0. I'm going to go to calculate the second trace, and I'm going to use the intersect feature. That's why I had to graph the second line for the intersection. Now with this one, since it's only crossing one place, I'm not going to move anything. I'm just going to hit enter 3 times. And there it is, -2. That's the way I'm going to do these. So in this next example, x squared minus 3x minus 40, all I'm really doing is setting it equal to 0 and solve. Now if you remember how to factor, you want to factor. If you don't, then do this. Let's graph it. X squared minus 3x minus 40. Graph it. Looks like it's crossing -5 and 8. And we can look at the table, but let's just assume that they're always not nice zeros. And I've already got the y2 equals 0 in there, so I'm going to hit second calc and then intersect, which is 5. Now this time I have to move it because I have a few of them. I have 2 of them. I'm just hitting the left arrow and notice it's somewhere around -5. So I'm actually looking at the x till it's close to -5. It goes off the screen, the cursor does, in case you haven't figured that out yet. But I know when it gets close to -5, it should start appearing. See that? See that? So now I'm going to hit enter 3 times. And there's one answer. So 1, 0 is -5. Now let's do that again. Second trace, intersect, and over here, I think it's around 8. Nope, so you can't hit the button on the second intersect. You actually have to move the arrow around. So I'm going to move the arrow. And I think it's around 8, so I'm actually going to look at the x because this flashing cursor is about to go off the screen. And so the reason why it does this because this is a -10, +10, -10, +10. That's all this is based on for now. So when the y value goes below -10, I don't see it anymore. So that's why I have to rely on my x, because I want to get close to positive x. So right arrow, and I'm watching this. until it gets close to positive 8. So now I'm around positive 2. When I get close to 8, I'll probably slow down a little bit. See that? Close. So let's hit enter. It doesn't really matter where you go, just as long as you're closer to that point than you are to that point. But to be safe, just close to it as you can. Hit enter 3 times. And there's the other answer, or the other 0. X equals 8. It's a neat little trick. Highly recommend it. In fact, I'm going to factor this using the calculator, using the same process, because you're going to be using this quite a bit, or can use this quite a bit as you do college algebra. Now, I probably already have factoring videos set up for you to look at if you need to look at the factoring. Watch those all that you want. I'm going to use the graphing calculator to help us out. Now, with factoring is the distributive property backwards. There's actually 3 or 4 or 5 main ways to look at things. The first thing you always look for is a GCF, which is what's common to both numbers, or both terms in this case. So let's see if I can use a calculator to help me out a little bit. So let's say I type in 3x plus 12, and I graph it, and I see the intersection, or where it's crossing the x-axis. So I'm going to hit second trace, 5. Since I only have 1, I'll hit enter 3 times, and we get x equals 4, or negative 4. Now that's what the 0 is, but what I can do though is I can move the negative 4 over to the same side as the x by adding 4. And when I do that, I get x plus 4 equals 0. Now I don't care about the 0. All I care about is x plus 4. So that means is one of my factors is x plus 4. But that doesn't equal 3x plus 12. So I think, what do I multiply x by to get 3x? Well, 3. If I multiply 3 by 4, I also get that 12. So that means my other factor is 3. So that's how it factors. 3 times x, 3 times 4, or 3 times parentheses x plus 4. It's a backwards way of doing factoring to calculator. And you may like it better, I don't know. And then again, you may hate it. I don't know. Let's try this next one. 4x squared minus 8x. So let's go to intersect. And this time we do have 2 zeros. So I'm going to move. Well, let's just keep it right where it's at and hit enter 3 times. And we get x equals 0. That's always good because that means that one of our factors has an x in it. Let's do second intersect again. Let's move it over to where everything is crossing. Hit enter 3 times again, and we get x equals 2. Once again, I don't want it to be 2, I want it to be a 0, so I'll subtract 2 from both sides. And I'll use x minus 2. Now, it's not correct. The reason why it's not correct, because if you multiply x times x, we get x squared, and we want 4x squared. So that must mean we need a 4 in front of that. I can't change that one. Or I could, but I still got to take the 4 out, so I'm going to put it in front. So, let's check it now. 4x times x is 4x squared. 4x times negative 2 is a negative 8x. That can't factor any further, and neither can that. So we're done. It's a backwards way to factor. Once again, if you don't like this, I do have videos. Hopefully you should be seeing the link to where you can watch those videos. I'm just showing you maybe there's a backwards way of doing things. Let's do this next one. X squared plus 6x plus 8x plus 48. Sometimes you can just look at the table and find where y equals 0. This y2 is my y equals 0 because I'm only looking at the y1. And by the way, at the graph, they look like they were in the negatives. So that's why I'm going to the negatives, negative x values. And there's my two zeros. Sometimes the graph is good enough, or the table. So I have x equals -8, and I have x equals -6. So once again, I'm going to add 8, and that's going to be one factor. I'm going to add 6, and that's going to be my second factor. And I'm done. That's it. If you multiply it out, you will get this. The only time I have to worry about other things is if there's a GCF, and there's no GCF. No GCF in this one either. Let's do this one then. X squared minus 7x minus 18. Let's look at the graph. Crossing two places. First thing I might try is look at the table. I have one that's a negative small and a positive big. So there's one of them already. X equals -2. So let's go back to positive x values because I saw one over there. Hopefully I can find it at the calculator. Oh, there it is. X equals 9. Add 2. We get x plus 2 is one factor. Subtract 9. X minus 9 is the other. If you were to multiply it out, full method, you'll get that. Let's do these last two. See what happens. 6x squared plus x minus 35. Now if you look at these, it doesn't look as if they're crossing exactly. If you look at the table, see -9, 22, there should be a 0 between those two, but I don't see it. 16, -13, there should be a 0. So what that means is I can't use my table, but I can use my intersect feature. So let's go to the first curve. Looks like it's around -3. So right somewhere's in there. Hit enter 3 times. Let me get -2.5. Let me write that down. We don't like decimals, by the way. Second trace, intersect. Let's go to the next one. Looks like it's around 2, +2. Once again, I'm looking at the x here. When it gets close to 2, I'll slow down. See that? Hit enter 3 times. And we get x equals 2.333, so on, so on. So here's what we're going to do. Second quit. I'm going to type in -2.5, math, frac, enter. And what that does is, it changes it to a fraction. Now I'm going to do the same thing to 2.33. Now I don't know how many 3's it takes, but I like to go to the very end. Then hit math, enter. And that gives this x equals 7/3. Now watch this. We're going to solve for x. Make this equal to 0. I mean, not solve for x, but make this side equal to 0. So first thing we want to do is eliminate the fraction. So we're going to multiply both sides by 2. And we get 2x equals -5, because those cancel. Then we're going to add 5. And we get 2x plus 5. Well, lo and behold, that's one of our factors. Then on this one, we just multiply both sides by 3. We get 3x equals 7. Then subtract 7. And what do you know? We get 3x minus 7. Don't believe me? Well, watch this. I'm going to check it. I'm going to pull it out. 2x times each of those is 6x squared minus 14x. Then 5 times each of those terms is 15x minus 35. And we have our like terms, minus 14x plus 15x is plus 1x or just a plus x. Then minus 35. Is that what the original polynomial was? Let's see. 6x squared plus x. Sure is. Checks out. Now let's do this last one. The reason why I'm doing this is because you may be using this quite a bit to find zeros of polynomials. So remember that when you come to those in your class. Just look at the table. It looks like it's around 1, but it's not telling me anything really. So I'm going to use my intersect. So hit enter 3 times. And just thinking about it, we get 1.33333. That's actually 333 again. So let's quit on that one. Let's do 1 point. How many 3's do we need? I don't know. Keep on going. Math, enter, enter. We get x equals 4/3. Now, that's the only one that pops up on the graph. The only one. So let's go ahead and solve that one. Or make it equal to x, I should say. Multiply both sides by 3. And then we're going to subtract 4. And 3x minus 4 is one of our factors. Now here's something you're going to learn in college algebra. Are you ready? In fact, I'm going to show you something else first. We know that since it's a square, it's going to be a binomial times a binomial. So let's ask ourselves, what's 3x times what is 9x squared? Well, how about 3x times 3x? And then negative 4 times what is a positive 16? Well, how about a negative 4? If you fill it out, do the outers and inners, you'll get negative 12x, then negative 12x again, which is negative 24x. Well, here's what you're going to find out in college algebra. Anytime it's like a touch and go, kind of like looks like that, that means it has more than one of the same zero or the same factor. Since there's more than one, you're going to find out in college algebra that that 2 means there's only 2. So that means that it has to be 2 of them. So either way you write it is like this. So this is like a preview to college algebra. But still is a backwards way to factor. So you still can do it. Once again, you may want to watch the factoring videos. But if you don't know how to factor, this may be a little bit better. If you do watch the factoring videos, you may want to use the ones that emphasize the graphing calculator because there's still some shortcuts in there. Totally different than this though. And as always, ask questions.